Okay, so we're looking at a series of about 9 pages of revision questions for the probability. So again, we'll just be pausing at the end of each question and you'll have a go. So here's the first one. There are 4 different maths levels, 3 different sciences and 5 different arts. If you have to choose one from each, how many do you get? How many choices do you get? So pause, and when you're ready, come back. Okay, so this is just the multiplication principle. Get on the pen. So the number of ways. Okay, so we've got 4, then we've got 3, and then we've got 5. So 4 3s are 12, so there are 60 different ways, different things you can do. Selections. Okay, so that's just straightforward, the multiplication principle. Okay, moving on. Okay, so just distinguishing between permutations and combinations. How many ways can you choose 3 things from 8 if 1, the order is important, or 2, the order is not important? So pause, and when you're ready, come back live. Okay, if the order is important, we've got 8p3. If the order is important, it's 8c3. So then it's just using your calculator. I'm just getting my calculator going. 8p3. Okay, 8p3 is 336, and 8c3 is 56. Okay, so that's that one there. So if the order is important, it's a permutation. If the order is not important, it's a combination. Okay, moving on. Okay, so we've got red balls, green balls in the bag, and you take 3 balls out without replacement. So without replacement means the probabilities will change. What's the chance of getting 3 reds, at least 1 red, at least 1 green, and at least 1 red? Okay, so this you can do this with the tree diagram or any way you feel like it. And pause, and when you're ready, come back live. Okay, hopefully you're back. Okay, so there's 5, there's 3, there's 8 balls to start with. So the first red ball is 5 eighths, and then we're taking balls out without replacement, so it's 4 sevenths, and then 3 6. Okay, 20, so it's 60 over, oh God, 56 times 6 equals 336, and then cancel that down. 60 over 336, and that equals 5 over 28. Okay, at least 1 red and at least 1 green. So there's more than one answer that's possible. So we've got, the answer could be 1 red and 2 greens, or it could be 2 reds and 1 green, and then you've got at least 1 red and at least 1 green. So we need to do both of these answers. Okay, so it doesn't say what the order is. I think we have to allow for that to happen. I'm just trying to think. Yeah, so orders. So we've got 1 red. So 1 red is 5 over 8, and then the greens are 3 over 7 times 2 over 6, and then that answer, because the red and the 2 greens could be in any order, so we multiply that by 3. I'm thinking this is the right way, so 5 eighths times 4 sevenths times, we haven't taken a green out yet, so that's going to be 3 6, and it times that by 3, and then we add them at the end. Okay, so 5 over 8 times 3 over 7 times 2 over 6 times 3. So that answers, so the first answer is 15 over 56, and then we do, okay, 5, 12, 20, so it's 60 over 336 times 3. So that's 15 over 28, and then when you add those two fractions together, 15 over 28 plus 15 over 56, the answer is 45 over 56. So I think that's the right answer for that one. Just have to account for the fact that the red could be in any of the 3 positions. Now, at least 1 red, which means 1 red, 2 reds, and 3 reds. The easier way to do it is 1 minus no reds. Okay, that's the quicker way to do it. So if we're going to get no reds, that means we're going to have 3 green balls. So 3 greens is 3 eighths, 2 sevenths, 2 sevenths, and 1 6. So the 6's cancel out. So that's 1 over 56. So 1 minus 1 over 56 is 55 over 56 would be the same as doing the 3 answers the hard way. Okay, moving on. Okay, the probability of passing the next exam is 0.9. It's probably closer to 1, hopefully. If you've got 6 students in the class, find the probability that exactly 5 pass, at least 1 passes, no more than 4 passes. So this is a binomial. Okay, binomial probability because it's 2 things, passing and failing. So have a go, and when you're ready, come back live. Okay, so we don't care who the 5 are, so the order's not important. So it's 6C5. We want 5 to pass, and we don't want anyone to fail, but in this question we want 1 person to fail, unfortunately. So we've got 6 times 0.9 to the power of 5 multiplied by 0.1, and that answer is 0.35. Again, 3, that's the 4 decimal places. Okay, at least 1 passes is 1 minus none pass. That's impossible. None passing. So 1 minus, everyone fails, so the chance of getting fail is 0.1, and we need 6, so that's impossible to happen. So 1 minus 0.1, clear, 1 minus clear, 1 minus 0.1 to the power of 6 equals okay, so 9, 9, 9, 9, 9. So it's impossible, 1.0. So at least 1 passes, it's 1.0. Okay, no more than 4. So that's 0, 1, 2, 3, 4. So the only answers you don't have are 5 and 6. So it's quicker to do the 5. That's the answer we want, 0 to 4 pass. So we just do the 5 and 6 passes and subtract from 1. So it's 1 minus probability of 5 and 6. Now we've already done the 5, haven't we? So we've got 5 up there, which is 0.3543. Probability of 6 passing is 0.9 to the power of 6. 0.9 to the power of 6. Okay, so that's 5, 3, 1, 4. And so plus 0.3543. So those two numbers add up to 8857. So this answer is going to be 1 minus 0.8857. There's a decimal. Okay, so no more than 4 passes, 0.1143. Okay, moving on. Okay, there are 6 students to be arranged in a straight line. How many arrangements are there with no restrictions? The shortest person's first, and two particular people can't be together. So this is hopefully straightforward. When you're ready, come back live. Okay, so no restrictions. We've got 6 people, so it's just 6 factorial. I think that's 720, but we don't need to worry about it. The shortest person's first, so there's only one shortest person, and then the others are multiplied, arranged factorial, so that's 5 factorial. Okay, so 2 particular people can't be together, so we put them together. So instead of having 6 people, we've got a group of 5, which is 5 factorial, and then the 2 people arranged are 2 factorial, and so therefore people not together is the unrestricted case, which is 6 factorial minus putting them, this pen's going a bit funny, putting them together, so it's minus, so whatever that equals, that's the answer. Okay, so when you have can't, you do them and then you subtract from the unrestricted. Okay, moving on. Okay, there are 5 chem books and 4 maths books on the shelf. Find the probability that the subjects are together. Okay, so it's probability, not counting again. A maths book must be first and the subjects are in alternating positions. So have a go. Okay, you're back. Okay, so we've got 5 chem books, so they can be arranged in 5 factorial ways. Okay, the 4 maths books can be arranged in 4 factorial ways, and then there's 2 groups of books which are together, so we're going to multiply that by 2 factorial. So 5 factorial is the chem books together, 4 factorial is the maths books together, and then there's 2 groups which is 2 factorial. Okay, next one says a maths book must be first. There are 4 maths books, so there's four choices for the first position, and then after that there's no rules, so the other 8 books is just 8 factorial. Okay, the subjects are in alternating positions, so we have to start with the science book because there's more sciences, so we can't start with maths. So science, maths, etc. So the positions will be 5 and then 4, then 3, and the maths books will be 4, then 3. So this one will just be 5 factorial times 4 factorial. Okay, because these are just going to the science books are just going to alternate. So it'll be 5, 4, 3, 2, 1, and the maths books will be 4, 3, 2, 1. So that's a factorial. Moving on. Okay, committee of 5 is to be chosen from 4 and 5. How many committees are possible if there's no restrictions? A majority of women, but there must be at least 1 man, and a husband and wife who are part of the people can't be on together. Okay, so the can't be is again important. Okay, so have a go, and when you're ready, come back. Okay, so if there's no restrictions, we've got 9 people, and we need to pick 5, so it's just 9C5. 9C5 is 126. So if the questions were a probability, that's what we're going to divide by, but these ones are just counting questions. But if there's a probability, that's the number in the denominator. Now, the next one, there's a majority of women, so but there's got to be at least 1 man, so we could have 4 women, 1 man, 3 women, 2 men, and that's it. We can't have 5 women because there'd be no men. We can't have 2 women because then there'd be 3 men, so there's those 2 committees. So we're going to get those calculations and add them. So we've got 5C4 times 4C1, whatever that equals, and 5C3 times 4C2, whatever that equals. So that's going to be 20 for that one. 5C3 multiplied by 4C2. Okay, that's 60. So altogether, there's 80. Now, in Part C, it actually doesn't say which committee, so we have to consider that as the no restriction committee. Okay, so it doesn't refer to a particular committee, so we have to assume that it's the unrestricted case. Otherwise, they would say what it was. So in the unrestricted case, which was 9C5, we have to look at that number. So what we do is we put them on the committee. So if they're on together, that would be 7C3. We've only got 3 people left from 7, so 7C3. So that's 35 committees. And so therefore, not on together equals the unrestricted case minus the 35, and 26, 9, that gives you 91. So there's 91 committees. Okay, so just remember, that question there didn't say what committee, so you have to assume it's the unrestricted case. Okay, 2 pages to go. Okay, how many ways can you arrange the letters in the word Bronte, Armand, Elise? So this is just straightforward ones as well. So pause, and when you're ready, come back live. Okay, this one, Bronte, 1, 2, 3, 4, 5, 6. So it's 6 factorial, and B, there's no other B's, there's no other R's, there's no O's, N's, T's, and E's. So the answer is just 6 factorial. Okay, with Armand, 1, 2, 3, 4, 5, 6. So we've got 6 letters again, and there are 3 A's, so we divide by 3 factorial. It's whatever that number is, you can do that yourself. And Elise, 1, 2, 3, 4, 5. And we've got 2 E's, so we just divide by 2 factorial. So it's whatever that number is. Okay, you can calculate those yourself. And last page. Okay, how many numbers between 1 and 200 are divisible by 2, 5, or 7? So this is the inclusion, exclusion principle question. So pause, and when you're ready, come back live. Okay, so this is going to be event A, event B, event C. So the number in A equals 200 divided by 2. So we've got 100 numbers. The number in B equals 200 divided by 5 equals 40. The number in C equals 200 divided by 7. So that's not going to go evenly. Divided by 7. So that's 28. So there's 28 numbers. Okay, the number in A and B, which is 2 and 5, is 10. So that's 200 over 10, so that's 20. The number in A and C, okay, 2 sevens are 14. So we do that calculation, 200 divided by 14 and equals 14. The number in B and C equals 200 divided by 5 sevens are 35. 200 divided by 35 equals 5. And the last one we have to do is the number in A and B and C, which is 200 divided by 2 5s are 10, divided by 70, that's only 2, I think. 2. So the number in A or B or C equals A plus B plus C, which is 140 equals 168, minus 34, 39, and then add 2. So 168 minus 39, it's 131. And that's the end. So I hope you enjoyed another video. Hopefully will come from Vectors tomorrow morning. Okay, bye.